Welcome back to our website. We are now going to go ahead with the examples dealing with the other formula, others call it other formula, which are calling the auxiliary angle formula. So the example goes, use auxiliary angle formula to solve the equation 3 tan theta minus 2 sec theta equals 4. Again, for 0 degrees, let's equal to theta, let's equal to 360 degrees. Let's look at our solution. We have given the question is 3 tan theta minus 2 sec theta equals 4. So can we first look at those identities? Tan is the same as sine over cos. Minus 2, what about a sec? Is the same as 1 over cos theta equals 4. So we multiply this out by cos. We are going to remain with 3 sin theta minus 2 equals 4 cos theta. Can we rearrange it? It is going to become 3 sin theta minus 4 cos theta equals 2. So can we look at one identity which was bringing 3 sin minus sine? We can say from r sine into theta minus alpha equals a constant, which we have already got here. So we expand this. I can say this is a equation star. Can we expand this? We are having r sine theta cos alpha minus r cos theta sine alpha. So can we try to rearrange it in that manner? It becomes r cos alpha sine theta minus r sine alpha cos theta equals our constant. So can we start comparing? I can say this is hash. We say comparing star with hash. So can we compare? We are having r cos alpha equals 3. Because you can see sine. We say r cos alpha equals 3. This is the first equation. We also go to another one. R sin alpha equals 4. We say this is the second. And our c equals 2. So c equals 2. From there, we have said c equals 2. Can we now look at 2 divided by 2 to create a tan? 2 divided by 1. So when you say equation 2 divided by 1, we are getting r sin alpha out of r cos alpha equals 4 out of 3. So r disappears. So I've remained with sine over cos, where we get tan alpha. So our tan alpha equals 4 out of 3. How do we get alpha? We look at the tan arc of 4 out of 3. So what is the tan arc of 4 out of 3? So we are going to say shift the button of tan into 4 out of 3, close the bracket, equals, we are getting 53.13 degrees. So we are getting as 53.13 degrees as the value of alpha. So we need now also to go ahead and we also look at the value of r. We can say equation 1 squared plus 2 squared. What is equation 1 squared? We are having r cos alpha squared plus r sin alpha squared equals 3 squared plus 4 squared. So here we are getting r squared cos squared alpha plus r squared sin squared alpha equals 9 plus 16. What is common here is r squared into cos squared alpha plus sin squared alpha equals 25. So we are remaining with r squared equals 25. So what is r? R is already a 5. After getting the square root of 25, we are coming out with that. Then we are free to substitute in our expression, which was saying r sine into theta minus alpha equals a c, where we have got our r. Our r is already 5 sine of theta minus. Do we know our alpha? Our alpha is already 53.13 equals our c is already a 2. So can we divide both sides by 5? We are remaining with sine of theta minus 53.13 equals 2 out of 5. So we remain with theta minus 53.13. We are getting the sine arc of 2 out of 5. So can we press still on our calculator how we get the sine arc of 2 out of 5? So we need to press the sine arc of 2 out of 5 on our calculator, and we see what it is bringing. So we are going to say shift sine of 2 out of 5. So we are coming out with 23.58. So we are getting theta minus 53.13 equals, after getting the sine arc, we are getting as 23.58 degrees, comma, we need to get other angles. We have got the first angle here as 23.58 degrees. Remember also sine lies in this quadrant. So we are going to say 28 to get another angle here, 180 minus that. So we are going to say 180 minus 23.58. We are coming out with 156.42 degrees. So how do we get theta alone? This one is a negative. When it goes there, it is being added on each and every number. So the first one will be 23.58 plus 53.13. You are coming out with 76.71 degrees, comma. We also add another one, we say 156.42 plus 53.13. We are coming out with 209.55 degrees. So these are the answers or the angles from the required equation. You have seen how we have applied the auxiliary angle formula in order to come out with this kind of the solutions.